Hello everyone, myself Kapil Meena of Integrated MSc Physics 3rd year. In this video, I am giving a presentation on the chip known as 8255. 8255 is called as Programmable Peripheral Interface. It provides an interface between a microprocessor and I/O device. Let me give you introduction about its block diagram. So the given figure shows the internal block diagram of 8255. It consists of data bus buffer, control logic, group A and group B control. So let us see each part one by one. So first of all, we have data bus buffer. It is a tri-state bi-directional buffer which is used to interface the internal data leads of 8255 to the system data bus. Input or output instructions executed by the CPU either read data from or write data into the buffer. Next one is control logic block. The control logic block accepts control bus signal as well as input from the address bus and issues command to the individual group control block. It issues appropriate enabling signal to the access the required data, control words or status word. It also has two group control which is known as group A and group B control. Each of group A and group B control blocks receive control words from the CPU and issues appropriate commands to the port associated with it. 8255 also has three ports which are generally known as port A, port B and port C. So let us discuss all of them one by one. So port A is it can be programmed in three modes: mode 0, mode 1 and mode 2. So port B, it can be programmed in two modes: mode 0 and mode 1. And last one is port C. So port C can be split into two parts and each can be used as control signal for parts A and B in the headshake mode. Now it can be programmed for bit reset or set or reset program. Now let us discuss the functioning inside 8255. The source or destination register within the 8255 is selected by a 2-bit register select code. Depending upon the values of chip select A1 and A0, we can select different parts in different mode as input output function or BSR. A write bus cycle to the 8255 with the register select code A1 A0 is equal to 11 and an appropriate control word is used to modify the control size. Now let us discuss the input and output cycle in 8255. The chip select input must be logic 0 during all read or write operations to the 8255. The reset is used to initialize 8255. The 8255 IC provides one control word register. It is selected when A0 is 0, A1 is 1, chip select bar is 0 and write bar is 0. A write bus cycle to the 8255 with register select code A1 is 0 equal to 11 and an appropriate control word is used to modify the control register. Now let us discuss different modes of operation in 8255. There are two different control word formats which specify two basic modes. First one is BSR mode, which is bit set reset mode. The two basic modes are selected by D7 bit of control register. When D7 is equal to 1, it is IO mode, and when D7 is 0, it is a BSR mode. First let us see BSR mode in. It is a port C bit set reset mode. The individual bit of port C can be set or reset by writing word in the control register. The control word format of BSR mode is shown in the below figure. The pin of port C selected using bit select. Bits and set or reset is decided by bit select or reset. The BSR mode affects only one bit of port C at a time. The bit set using BSR mode remains set unless and until you change the bit. So to reset any port C, bit pattern is loaded in control register. So now let us discuss what are input output modes. As we know, the most significant bit MSB of the control word describes the mode in which 8255 will be. For the IC to be in the input output mode, the MSB must be set at 1. There are three input output modes of operation. Those are mode 0, which is basic input output. Next one is mode 1, which is strobed input output, and the last one is mode 2, which is bi-directional input output. Now let us discuss each mode one by one. The first one is mode 0. Now in this case, no port performs the handshaking function and all the ports, that is port A, port B and port C, act as a input output for the transferring the data. This mode is capable of handling the interrupts. The output are latched but the inputs are not latched. So these are some important functions of mode 0. So let us move to the next one. The next mode is mode 1. In this mode, either port A or port B can work and port C bits are used to provide handshaking. The outputs as well as inputs are latched. It has interrupt handling capability And before actual data transfer, there is transmission of signal to match speed of CPU and printer. Let us take an example for better clarification. Let's say when a CPU wants to send data to slow peripheral device like printer, it will send handshaking signal to printer to tell whether it is ready or not to transfer the data. When printer will be ready, it will send one acknowledgement to CPU, then return there will be transfer of data through databus. Now let us discuss this timing diagram. We know it's not a time-based operation, it's a sequence-based operation. The first signal is strobe. By giving strobe device is saying that it want to transfer data. Data is transferred from input device to 8255. The moment 8255 gets the data, first thing it will do is prevent the IO device to send another data. So immediately it will make the IPF go slow. Now 8255 has to inform the processor that it has the data. For that it will give the signal INTR and make INTR goes high. In response, whenever free, MUP will make read bar go low and it start reading the data. When read bar is low, that is there is transfer happening from 8255 to microprocessor, and since this procedure will continues. So it's all about mode 1. Now move to mode 2. So let us discuss what is mode 2, which is also known as bidirectional input output. In this mode, only port A will work. Port B can either be in mode 0 or mode 1, and port C bits are used as handshake signal. The outputs are as well as input are latched. It has interrupt handling capability. Port A required 5 signals from port C for doing bidirectional handshake. The port B has several options. First of all, the first option is it can use the remaining 3 lines of port C for handshaking, so that port B is in mode 1. Hence port C lines will be completely used for handshaking. The other option is port B works in mode 0 as simple IO. In this case, the remaining 3 lines of port C can be used for data transfer. The last option is port A can be used for data transfer between two computers as shown in the figure. The high-speed computer is known as master and the dedicated computer is known as slave. Handshaking process is similar to the mode 1. So in the end, let us see the timing diagram of mode 2 as well. By default, INTR is high, microprocessor gives write bar. Once it gives write bar, that means there is the data transfer from microprocessor to 8255. Immediately INTR goes low. Once INTR goes low, microprocessor doesn't have the permission to send the next data. And now the data is secured with 8255, and 8255 immediately puts the data on output port and sends the data to the input output device and has to inform the microprocessor that now I am free, you can send the next data if you want. And this procedure continues. That's all in presentation. Thank you.